Hello, stream watchers. It's Friday, February 1st, 2019, at 1 o'clock Pacific Standard Time. I'm Bobby Johnson, coming to you live from Olympia, Washington. Today, we're going to be continuing to work on Broxburn, which, if you did not see the previous stream where we started this project and kind of explained the goals for it, you can find a link to the video recording right here in the GitHub repository. Simply go to github.com/notmyself/Broxburn and click on the projects tab, and then look at the completed project down at the bottom. And this is kind of a pattern that I do with my streams, is I take a few minutes before I get on and kind of plan out what I'm going to do, and I create a project for the episode on GitHub with some cards of specific items that I want to cover, that sort of thing. So thank everybody for hopping in to watch me today. Ancient Coder popped in first. He's my first-time viewer for my stream. Happy to have you here, Ancient Coder. It looks like Rambling Geek is with me. Very happy to have you guys here with me live, and hopefully some folks will come in as we progress through the session today. Sure, Ancient Coder, I can do a brief overview of what Broxburn is. So Broxburn is an app that I'm going to be creating from scratch over a period of time. I'm kind of taking it a step at a time. I don't really have an idea what I want Broxburn to be. I just know that I wanted to build an app from beginning to end live as a series on my stream. So without an idea for what the app is going to do yet, I know there are some kind of housekeeping stuff that I can take care of. One of them is, setting up the GitHub repository, creating a walking skeleton of the application. I know that I want the back end to be Web API and .NET Core, and the front end to be a React.js application. So in the previous stream, we set up the React application, we set up the Web API Core application, kind of tied those two things together and stood them up to where you could see them running on my machine as just like a walking skeleton application. And then I took some questions, and that was about it. So if I jump over to today's project board for the stream, we can talk about what we're going to be doing today. And I received some feedback from several folks who watch my stream for the initial Broxburn episode. And one of the things that they said was, I'm a dev evangelist, so I'm used to standing in front of an audience and just talking without really much interaction from the audience and taking questions at the end. And Twitch is more really about, at least the folks that provided me feedback, more about watching someone struggle through or discover things on their own. So I invite you guys to come in and watch me kind of struggle doing these steps, because I haven't pre-planned them or pre-done them. In the previous session, I kind of had all the answers for how I was going to do things, so it came off a lot more presentation-y. So I did a minimum amount of prep for this session. But I did do my board because I still want to have set goals. Like, this is what I want to accomplish in this session. I'm planning on going for about an hour. If we go a little over that might be fine. But the amount of work that I have queued up here, I think will take about an hour to complete. So since this is an interactive thing, and I may stumble a few times, feel free to shout out in the chat, giving me hints of where I may be messing up, or if you just have a question about why I'm doing something in a certain way, that sort of thing, feel free to ask me questions. So there we go. You kind of get the feel for my stream now. I have a card, it tells me what to do. I click the little box when I complete it, right? So before we get started on the remainder of the cards, and kind of what we're going to be doing today is we're going to create a Docker build that creates a Docker image hosting both the React application and the .NET Core application. And we're going to get that working to where it actually runs inside the container. And then with the time that's left over, we're going to set up a continuous deployment pipeline using Zeit Now. So let's go over and take a look at where we're at right now in the application itself, just to give you an idea of what we did in the previous stream. We basically created 3 folders. All right, we have a client folder that contains the React application. If you've ever used the CLI tool Create React App, this is the exact output that gets spit out by the Create React App application. And then we have an API project or API folder that is a .NET Core Web API project. And a Web API project is really just intended to be, JSON services. So basically, I receive a request, I respond with a bit of JSON in there. And then the final thing that we did was I created a start script that just kind of fires up the application running locally, right? Pretty cut and dry. So back over to my project board. I've done with that. Let's go ahead and do a demo real quick to where you can see it actually firing up and running. So if I come back over here to the editor, what I can do is I can just say start or scripts, start, and that's going to do a build if necessary and a run of the Web API project. And if you remember from the previous session, what I did was I wired up Web API to host the React application inside it, where we stand up both applications, but they're both being served off the same port on my local machine. So if I come back up here, you can see that we're listening on port 5000 and port 5001 for HTTPS. I'll go ahead and open that up in the browser. We head back over here to the browser. You can see we have a React. I mean, just the Create React app output being served up on 5001. But if I add a API values, which is the only controller that I have currently, we see I've got a JSON API basically that will spit out values to me that I can consume from the React application. Right? Seems pretty straightforward. It does work. And what I like about this structure so far is that I have a single command that puts me in a development space where I can have the application running in the background, and I can be hacking on the React app and using the Create React Apps configuration to have live reload and all those, kind of niceties for development purposes. So the setup is pretty nice. And I can do it all from within my editor, which is very clean. So back over here to my plan. And so we've demoed that. So we're kind of done with the review state now. So the remaining items that we have left to do are to create our Docker image. And I'd like to use a multi-stage build for both the React and the .NET Core builds. Create an image from that build result, and then ensure that the image exposes the port properly. So the demo that I just did for you running on the bare metal of my machine, where I'd like to end up at the end of this card is giving you that exact same demo, but being hosted out of a Docker image or a Docker container. Excuse me. So let's go ahead and get started with that. Do you guys have any questions about what I'm going to be covering or anything? All right, cool. Well, I'll just go ahead and get started. And if anybody does have any questions, like I said, feel free to pipe up. So for Docker, let me come back to my browser real quick. I'm going to be running locally just Docker for the Mac, right? Docker desktop. And I actually need to fire that up because I don't have it running currently. So if you're running on a Mac like I am and you're unfamiliar with Docker, this is probably the easiest on-road to containerizing your app, your apps, and getting involved with Docker and how to use it and that sort of thing. Just install the Docker desktop for Mac, and you have everything you need to go, right? You just need to learn how to use Docker. Pretty straightforward. So back over here to the editor. Looks like my Docker is still firing up, so we'll give it a couple minutes. Oh, thank you, Ancient Coder. I appreciate that. Sometimes without having the audience like out there actually visible, I can't tell if I'm connecting or not. So I really appreciate your feedback. And Docker is fired up. I do have a Docker Explorer extension in Visual Studio Code that shows me basically all of the images that I have available right now within Docker. And right now I have basically the .NET Core 2.2 software development kit on an Alpine-based image. And then the .NET 2.2 ASP.NET Core runtime hosted on an Alpine image. I don't know if you guys can see that or not, but you see it right there. It's Alpine. The Zeit Core image up here is an image I was playing around with a couple of weeks ago. This is one I actually created myself. The two below it are actually Microsoft provided Docker images for doing exactly what we're going to be doing today, right? So those images, we're going to build our image on top of those. It's like a baseline starting place for us, right? And currently right now, I have no executing containers in Docker. So the idea is an image is like a blueprint for a container itself. The image has everything in it that you need to stand up a container that will then execute some bit of code, right? Does that make sense to everybody? Pretty straightforward. So images are the blueprint, containers are the actual executing environment sort of thing, if that makes sense to you. For registries, I really only have Docker Hub set up right now as a registry. Basically what that means is registries are sources of where you get the images that you start building your own images on top of. So Docker Hub is the big popular one that is out there that pretty much everybody uses, but it is possible for you to have private registries. So like you can have a registry inside your company that you build your applications into an image and publish them to. And then maybe your DevOps team or you're the DevOps team then deploys from your internal registry out to your production environments, if that makes sense. So let's head over to Docker Hub real quick, just where you know what that looks like. So you can really search here for any kind of Docker image that you want. Let's look for anything with Node. Let's say Node 8. Right, and so there are official images on Docker. So the Node team themselves have produced this particular project on Docker Hub. There are verified publishers. Microsoft has some version of Node that they're publishing out there on their own. And then there are also individuals. So individuals can publish their own Docker images out there for you to consume. And those can be really handy. Like say you're going to start working on a Jekyll website for work, but you don't have Ruby installed. You don't have Jekyll installed, none of those things. And really all you need to do is make a quick edit and then verify that your edit worked and publish that, right? Well, you don't want to install that entire tool chain to be able to do that sort of thing. A Docker image is perfect for that kind of development workflow, right? It already has all the tools installed on itself. You can volume map your local drive where your source is at and have it serve up the application to you. That's one local development practice that I like to use Docker for. So let's go back to the editor and let's get started actually building out our Docker container. And to do that, I'm just going to create a file called a Docker file. And a Docker file is, as you'll see, because I'm about to do it, is a definition of how to construct your image based on another image or files that are on your local machine, commands that you can issue to be able to get that image in a state to where it represents the run state of your application. Hi, Rambling Geek. Good to see ya. Hi, Brandon Satstrom. I think I pronounced that right. Please let me know if I didn't. And Adrian, hey, man, thanks for coming to my stream. I really appreciate that. So we're just getting started. with wiring up this Docker container. So I'm gonna start doing it. And the way you start a Docker file is you generally tell Docker where you're going to be starting from, like what baseline image are you going to be starting from. So you do that with a from command. And I'm going to start with the Microsoft's .NET SDK image, right? So Microsoft .NET version 2.2 SDK, and I want the Alpine version. And I'm going to call that build core. Right? Okay, so what this statement is saying is I'm going to start with the .NET 2.2 SDK Alpine image, and I'm going to call that build core. And I'm going to start now issuing commands against that base image to modify it to add my stuff on top of it. So first thing I want to do is I want to define a work directory. And I'm just going to start with app. Say, okay, so everything inside the Alpine image, I'm going to start working from a directory called app off the root of the Linux distribution. Right? So one interesting thing with this particular image, the .NET SDK, it doesn't actually come with Node. It is just the build tools for building .NET applications. But I would like to just use this one build core image as my starting place and get it working. And then I might look at using one of the Node-based images to build my React application. But for now, I'm just going to keep it one base image, do the build, and then create a secondary image for the actual execution environment, if that makes sense to you. So to get Node on this particular image, I'm going to use APK. So this is an example of executing a command on the Docker image that you're being based on. So I'm going to run APK add node.js and node npm. And I'm also going to bypass cache just to speed it up a little bit. I always want to get the latest version. I shouldn't say speed it up a bit. I always want to get the latest version of Node that's available, PK, right? So now I want to take my source control or my source files and copy them onto the image itself. And that's just simply copy. And I want to copy everything from my local machine. So starting at where I'm running the Docker file from, basically, into my current working directory, which is /app, right? I'm just going to copy those files. Once I have them copied, I'm then going to run a command to do a .NET restore. Once the restore is complete, I'll run another command to build all of my source, and I want to run that build in release mode. And then the final thing that I want to do is I want to publish basically a deployable version of that release build, right? And I'm going to output that to the app directory. I'm going to call it deploy. So that should give me a built version of my .NET application in the deploy directory. That makes sense. So now that I have a built version of that application, I'm going to start the next stage of my Docker file, because I said this is going to be a multi-stage build definition. Now I want to create a new image that is based off the ASP.NET Core runtime image that I'm going to take the deploy directory from my build core image and move the built assets onto it. So as always, we start with a from declaration. So from the Microsoft, let's see, how's it spelled? /.net, :2.2, core, runtime, Alpine. And I'm going to call this one runtime. Right. So once again, we also need to define a working directory. And I'll use the same app. So I'm defining the working directory in this new image that I'm creating. And what I want to do with this one, since we're building the application in release mode, I want to expose port 80 because release mode for the application happens to serve up on port 80. So expose 80. And then I'm going to copy all the files from build core into this particular setup. So copy build core. And from build core app deploy, I want to copy everything into my working directory for this new image. Does that make sense? All right, cool. And then finally, to actually stand this image up, what I need to do is create an entry point. So now that we have all the built assets in there, we need to tell Docker, okay, well, when you start the container, what command should I do to kick off the website? So we give it an entry point, right? And the executable that we want is .NET. And then we're going to pass it a parameter of our built output, which should be API. And let me just double check that. That name is actually based on what is set here in this API CSproj file. Yeah, so my project is named API, so that should be the entry point. There. Okay, now that we have a Docker file, we can give it a try to build it. So to build it, you open up a command shell and you type in docker build, and I want to give the image that it produces a name, right? So I'm going to call this Broxburn image. And I'm telling it to begin the build from the current working directory. Right, so go ahead and fire that up. And -b is not a known flag because I forgot to put the T in there. Right, and we'll let that build kick off. And while it's running, everybody cross your hands because I have not actually ran this build, this file yet. So it may work or it may fail. We'll see. So it did fail. And did it fail? Oh, I didn't completely name the APK package. So it's Node.js for the Node runtime and Node.js-npm for npm, basically. That way you can have like a runtime image for your Node applications that doesn't include npm. So I will go ahead and fire that off again. All right, so it successfully installed Node and npm for me. It's now on step 4, the copy. Is this step And my poor little MacBook Pro is trying to take off into orbit right now because of all the things I have going on. All right. Must specify a project or solution file to build, right? .NET run restore. We're at, yeah, restore. So because of the structure of the project that I have right now, I have the Docker file out here at the root of the project. And my API is in a subdirectory called API. I need to actually point .NET build process at that specific project. So I believe the command that I need to do is .NET build help file, an output directory, project name. So it's failing on restore, so I'm going to whack app API, excuse me. That, let's see if that works. I think this one will, or the restore anyway. You know what? I probably need to do the same thing for my build and publish steps. So I'm going to look up the help on those as well. Restore. Yeah, the project always comes last for restore. It does for build. Does publish work the same way? Oh, no. Yeah, project always comes at the end. So I'm going to add this segment to it. Let's give that Docker build another try. Yeah. I am kind of worried about all the things going on my machine just crushing my MacBook Pro. I might have to get a desktop or something like that if I'm going to be streaming regularly. Hey, Hugo Dahl, thanks for joining. I appreciate you coming. And I see Brave Cobra joined us as well. Very nice. Let's see. Brave Cobra. No, I have not done that yet. Why don't we do that while the build is running? Because these builds can sometimes take a while. So, what Brave Cobra is suggesting is that I do not copy certain resources that are inside this API directory, like my bin and my obj file, or directories. Those don't need to go over into the Docker container for the build process itself. And the way that you can do that is by creating a Docker ignore file, which works just like your git ignore, right? So I'm going to go ahead and create a new file, and I'm going to call it .docker ignore. And let's see, the things that I want to keep out of my Docker images are an obj folder, a bin folder, and probably node modules as well. And I don't want those things from any directory anywhere inside my project. So what I'm going to do is I'm going to precede those with ***. And what that says is basically any directory from where this file is located all the way down through the rest of the directories in this directory, ignore anything called obj, bin, or node modules. Don't do anything with them. All right, does that make sense? And just to be safe, I'm going to go ahead and close those off as directories. That. So thank you, Brave Cobra. I had forgotten to do that. All right. So let's see. It looks like the image did build. So if I come over here to my Docker pane, Docker Explorer, we can see we have an image now defined called Broxburn image. And if I want to run that image, now that I have it, what I can do is I can say Docker run Broxburn. Spell that right? Yeah. Broxburn image, and we're going to call it, I don't know, Broxburn. I'm going to go ahead and finding it, unable to find image, Broxburn image. Oh, I forgot a flag. So I'm calling out the image by name. And I have it exactly backwards. So let's take this one out here. I want to name the container Broxburn. And I want it to be based on Broxburn image. Sorry, I usually script these things out so that I type them maybe once every 4. So what's the problem now? You mean to run .NET SDK commands? Please install blah, blah, blah. That's neither here nor there. But if we look at my containers now, I have several images that are currently executing, right? Or containers actively running. I'm going to go ahead and remove all of those containers because these SHA-based ones are my failures earlier, and I don't want you guys to see my failures. So let's see, what else do we have to do? Now, we installed Node and NPM, but all we did really was we built the .NET application. We didn't build the Node application or the React.js application. So we need to build those assets as well. Right now, we are deploying the application to a deploy folder. We're copying it to the root of the app folder on the execution image. I don't want that. So what I'm going to say is start from our current working directory and deploy from build core to API. That works. So complete the build core, copy from the deploy directory into an API folder. But I don't want, let's see. If I'm going to build the Node application, I need to do that into the deploy directory as well. So I'm going to, let's see, copy the API to an API directory. All right. Like that. Let's try rebuilding that. So I'm just going to nuke the image and recreate it. I'll nuke the Zeit core image. All right. So not the run. Sure, Adrian. The reason I want to leave those folders out from copying in the image, the build image itself, the Docker ignore files, I don't want them to interfere with the build process in the image itself. So say I'm doing local dev on Windows or whatever, and I do a build locally, and I've created an obj and a bin folder or node modules folder on my local machine, and then I copy all the files, including those folders, into the image itself and try to do a build. Well, the image that I'm building on is not Windows or OS X. It's actually Alpine-based Linux. And those folders having content from a different operating system could potentially cause a problem. And those kind of problems are really, really evil to track down. So for me and Brave Cobra, we both know, just exclude those. Never copy them over because they're build results that are specific to the local machine, not the image itself. Yeah, okay. So if I go back, it does look like I get a successful Broxburn image being built. And I'm going to run interactive on that. And the reason I'm doing that is I want to do a quick, ooh, it failed. Did you? File. I think I know what this is. Let's dig into my API bin directory. And yes, it does. It actually produces a DLL, not an executable. So my Docker file is wrong. .dll. And we're going to have to rebuild it to make that change. Move that image. Rebuild. Oh, you had that same problem, little Bobby Tables? I'm sorry, man. I hate it when that kind of stuff happens. Okay, so that's gone. Let's go ahead and do my build again. Here's my build. Did I get a new bash terminal? What the hell? Don't do that to me. All right, so let's go ahead and rebuild it. So you guys might be curious, why am I bothering with creating a Docker image based on what is effectively template code, right? All I've done is used a couple CLI tools to produce the out-of-the-box Create React App application and Web API application. And the reason that I choose my next step to be building a Docker image is that there's no complexity in there yet, right? So if I can go from a bare bones application, deploying to a Docker image successfully and executing and serving up that application, and then out to an actual production deployment, I've kind of proved out my deployment pipeline for the application itself. And I started doing that probably 6 years ago after reading a book. Let me hop over here into my browser real quick. And this book was really, really popular in the Ruby community when it came out. It's called Growing Object-Oriented Software Guided by Tests. And the book is really interesting, even if you're not a Rubyist, because it talks about how to actively grow your software over a period of time in a way that's clean and that you have an easy way to verify that it works the way you want it to, right? And one of the concepts they have in there is they talk about creating a walking skeleton first, right? And when you start a project, at the beginning of the project, you have no idea really what you're going to be building. All of your Scrum Masters and maybe business analysts or whoever goes out and gets your requirements, if it's you, are probably talking to the customer and trying to figure out what it is we're going to build functionality-wise. But the engineering staff or your DevOps staff can get started at that same time by proving out the infrastructure, right? So we know we're going to build an app. It's going to be a web application. It's probably talking to Postgres. Maybe it is going to send emails using SendGrid, maybe use Twilio, something like that. So building a bare bones application that represents the various pieces of your app, and then creating a automated deployment pipeline all the way out into a production environment is a way of proving out that all that works. That way, when the functionality comes in from your requirements gatherers, you can start building applications and you're deploying into production every commit, right? And what that benefits you with, if you've ever worked on large enterprise type projects, sometimes the situation that you'll find yourself in is you work for 6 months, maybe 9 months, maybe a year. I've been on some projects they didn't deploy anything for 2 years. And then 2 weeks before everything is supposed to go live, they start trying to figure out how they're going to deploy it into their environment, right? And that is a huge headache. And that's how you hear about, deployments failing, right? All those sorts of things. So by setting the deployment pipeline all the way out into an environment before you even have a bit of functionality, you've proven that it can work, right? So every deployment, we're going out into an environment. We know that deployment pipeline is working, our tests are executing, and that the built assets that are produced actually stand up in the environment and work. And growing object-oriented software guided by tests is where I got that concept from. So I highly recommend picking up that book. So back over here to the editor. Looks like we are done with the image. I'm going to come up here to try to start this interactive again. And I could have done that directly from my terminal. Did it fail again? Oh, and it's not giving me any indication why it's failing. Pardon me, I got a text from my wife. All right. So, let's see. How can I troubleshoot this? This is a part that I was talking about at the start of my stream where I said I was going to be a little more unscripted. So now I've got to figure out why it's failing. So for my deployment, I did set the entry point. Inner files. See, I'm exposing 80. I'm going to look at my sample Docker file over. And you guys aren't seeing this, so I'll go ahead and show it to you. Here's my cheat sheet that I've been using. Browser, you can see it. So let's see. From Microsoft.net. Well, copying that stuff. Copying from build core. I did call it from build core to app deploy API. To an API directory. I wonder if I did a run ls API, if it would actually show me the files that have been dropped out to where I know that I'm actually getting what I think I'm getting. Back over to the editor to where you guys can see what I'm. That image, and I'm going to run my build process again. We can clearly see it's restoring the packages. You can see that right here. We're running the .NET build in a release configuration for just the API. And then we copied, come back here. Oh, this is the build. Where is the publish? So we're publishing output to deploy API project. Copied a API bin to the API DLL to deploy API. That looks right. So, oh, from my entry point. Is that what you're saying, Brave Cobra? My entry point should be pointing at the API directory. All right, let's give that a try. I think he's right. So I'm going to go ahead and nuke the image again. Move. All right. Did it actually spit out the contents of my API? Yeah, it did. So we can see the DLLs right there. I also got a PDB. I need to go into my CS Proj and disable that for release configurations into a production environment. I don't want to deploy PDBs. For you guys that are not familiar with .NET, PDBs are your debug symbols, basically. So with a release build in .NET, you can produce debug symbols for release build. But the reason you would want to do that is you get nice looking stack traces that refer to actual lines and files that exist. But it's exposing a little bit too much information to the general public for a production system, if that makes sense. So eventually I'll need to come back and get rid of that. Let's see, web config. All that looks right to me. So I think Brave Cobra is right. I did not set the entry point right. So I'm going to try rebuilding that. Sure. So debug symbols are when you build your application, like you take your source code and you produce an executable or a dynamic link library. You can also have a sidecar file called a PDB or debug symbols. that are basically what it does is it says, okay, this point of execution inside your executable refers to this line of code inside your source code. So when you actually go and hit F5 and say Visual Studio or Visual Studio Code in a .NET project, that's debugging the application. It's using that PDB to actually sync up the source code files with what's actually executing in the environment itself. Does that make sense, Bobby Tables? Yeah, cool. All right. So let's see if we can get it to fire up again. What am I doing? Refresh. I want run interactive. Oh, this looks positive. So it did run it. It is binding to 80 like I said it would. So theoretically, with this running in the container right now with, oh, you know what? I did miss an extra step. Nope, because when I ran it interactive, it actually did the port binding for me. And I'll explain what that means in a minute. Give me a second. I'm going to flip over to, let's see, it's listing on 80. But I exposed it as 80 to my host operating system. Let's see if that'll even come up. So you should be seeing my browser now. And if I go to localhost :80, shouldn't really need to do that, but I'm gonna give it a try. It is hitting that. That's cool. All right, so API values. And now I'm getting values out of the execution of my .NET application running inside the container. I'm surprised by that because usually OS X has port 80 already mapped to something, and you get some kind of big error when you try to bind to that port. So you usually have to use an off port. So that's why I was a little confused. So let's go back to the editor. You can see the requests coming through here. Here's the big error that I got because I don't actually have anything set up to serve as my root of the website or my index. So it blew up because .NET didn't know what to serve up. But yeah, it looks like it is going to work the way I want it to there. So I'm going to remove that container. I'll pop back over here to Bash and let me show you what I was talking about. So I was kind of looking at all this weird stuff here and saying, oh, it's on port 80. I'm surprised it's doing that. So when I right-clicked on the image and said run interactive, if you were paying attention, what it did was it spit out this command into my terminal to tell Docker to run my image. And run it as a container. And let's take a little closer look at this command and what it's doing. So we have docker run. What is RM? I don't remember what RM stands for. Bobby Tables, you got an answer for me on that? That you do. He'll pop in and let me know what it is. The thing that's interesting about this is that this -p is basically saying, okay, I want to do a port map. My container is running and I've exposed port 80 on the container. But I want to expose that port outside of the Docker environment to the actual host system. And the way that I would normally do something like this is I would call this like 5000, right? So I'm saying, hey, port map, port 80 in my container to the host environment's port 5000, right? Remove after running. So when I shut down, it automatically just nukes the container. Yeah, thanks. So without right-clicking and using my IDE to solve this, I should be able to run this this command and stand up a container just like I did with the Docker Explorer. And that should map port 5000 for me. So if I come back to my browser and I refresh this page, I should get an error. I do. So I'm going to 5,000 instead. And wow, get a bunch of stuff. I run the right image. Broxburn image. /values. And this is really interesting. I'm kind of confused why I'm getting this because I haven't deployed any of the React application itself. And this is actually the client UI React application. And I'm getting that just from the root. I'm curious how that happened. What was actually deployed in this environment? Hey, Bobby Tables, what's the command to just get a shell inside the executing container? Let's see if I can look that up right now. Docker shell to a container. Start looking at my browser so you can see what I'm doing. ID of running container. So let's figure that out. Docker PS, show me all your running containers. So I only have one running container right now. And Docker PS is kind of like PS on your root operating system. It shows you all the processes that are running inside the container. I only have one. This is my container ID. That's the thing that I need. And you guys can't see what I'm talking about. Flip over to my editor. We can see it's based on the Broxburn image. Command it's executed is .NET API, API DLL, and port mapping to the host system. So I'm going to go ahead and connect to it. Exec-IT, which I believe is for interactive. I'm going to put the ID in there that I did not. And bash. Cannot find bash, so let's try root usr bin bash. That's not it. Does anybody know the location of bash on the ASP.NET Core runtime Alpine, or on Alpine really? Where is Alpine? Let's try Googling that real quick. So back over here, running container Alpine. Oh, there is no shell. Let's look here, see what it says. Ash. What was that? You think that's a typo? Huh. Let's give it a try. We're gonna do /bin. Only sh. Let's just try sh. Hey, it let me. So we have I. Oh, that's the API directory. So ls API. There's all the things we deployed. Once again, you guys can't see what I'm doing. So I connected to an interactive shell in my executing Docker container, my running Docker container. And I did an ls to show me all the files inside my API. Now the question is, how on earth is it serving up my React application? There are no React files in there. What all did I copy over? This API. Did a deploy API directory, and we copied that. This should be the only files in there. Wow. Okay. Well, I'm at a loss. Anybody have an idea of how that's working? That's pretty cool. It's not cool. I'm a little baffled. I want to know exactly why that is working. What if I back up a directory? What's here? Bin dev home proc spin serve sys. I don't see anything there that would not be my app. Okay. Well, I'm going to head back over to my browser, and we're going to look inside the Broxburn board for this particular episode. We did create a multi-stage build for React and, or at least .NET Core. We are creating an image from the build results and are ensuring that the image exposes the port to the host machine. I'm not sure how the React stuff is working, so I'm going to have to dig into that maybe off camera for a while. And we're running about 7 minutes long. I don't want to take up any more of your guys' time. I'm sure somebody else wants to stream something really fun. And next Wednesday, I'll come back and start right from this starting place. Right? All right. See you guys.